Okay, so that brings us to our final talk for technology and innovation, and this is going to be a very special surprise. One of the most ubiquitous buzzwords of 2017 has been artificial intelligence. But what does AI actually mean, and what are the applications for a huge, global, creative industry like fashion? I'm pleased to welcome Amit Sood of the Google Cultural Institute to share some insights on how this groundbreaking technology has impacted other creative fields and share the details of a new partnership with BOF.
So what I will do is, rather than lecturing you about machine learning, because just so you know, I'm not an expert in machine learning. What I have been doing at Google is something different, and I'll come to that in a second. What I think we'll start with is a quick video where I'll get others to lecture you about what's happening in machine learning and AI. And these people who you're going to hear from in the video are actually at the leading edge of what is going on in this field, which is very, very young. So keep that in mind. And I'm going to try and hopefully the video will play. Yeah. Do I have to click? No. You do need volume, though.
There have been a number of shifts in the way we think about computing over the past few decades.
The terminology artificial intelligence has come in and out of favor in the scientific community. Sometimes it's called machine learning.
We tend to call it machine intelligence these days.
I just call it intelligence.
And sometimes it's just the effort to build machines that are better.
So in the early days, everything was built on logic, doing mathematical integration problems, playing chess. But we realized that what the real challenges were the things that people can do every day.
The real world is actually very messy. Hard logical rules are not the way to solve really interesting real-world problems.
You have to have a system that'll learn to get the knowledge in. You can't just program it all in.
Artificial intelligence is an effort to build machines that can learn from their environment, from mistakes, and from people.
And we're still at the stage where we don't know what is the right path and the right breakthrough.
So, I mean, there's certainly a whole raft of different approaches.
One of the subfields we call pattern recognition.
Artificial neural network.
Reinforcement learning, for example.
Statistical inference and probabilistic machine learning.
Supervised learning, unsupervised learning. And we're not quite sure what technique is going to lead to better systems. And in fact, it's probably not one technique for everything. It's probably a bunch of different techniques and combinations of those techniques.
Any progress we make in building truly intelligent systems is going to depend on progress in technology generally.
And until recently, we didn't have computers that were fast enough or data sets that were big enough to do that.
And so being able to take a particular problem and spread it out over lots and lots of machines is a very important approach because it makes our research faster.
So there's applications of artificial intelligence around us all the time.
When it begins to work, or it does work, it's all of a sudden given another name.
We're all already using it and very comfortable with it.
Things that now we regard as routine, 30 years ago would have been regarded as amazing examples of artificial intelligence.
Anti-lock braking.
Autopilot systems for planes.
Search.
So I'm going to pause that video there because I think I want to just end with that last part very quickly, is that it's a new buzzword, but it's been around for a while. And you should probably go on and understand more about that thought, because I'm not going to lecture you further. What I will do, though, is I will now start showing you, what I do and what my relationship is with this talk. Because, oh yeah, and that's a helpful way to think about it as well. Easy definitions, I'm not going to read it out. I think you all can. But in case someone asks you, you can leave this talk saying I at least learned the difference between AI and ML. All right, so moving on very quickly. What I'm going to do is I'm going to talk to you about the fact that what I do. So I started a 20% project in 2011 at Google, which really was not about machine learning or anything. It was really about finding a way to change the perception of most of my friends in Bombay who thought going to a museum and enjoying artworks was for rich, fancy people. And I never went to a museum until I actually came out of India. I always thought it's not for me, it's not my cup of tea. And then I started living in New York in my early days, and I fell in love with the MoMA, like most people do. I fell in love with museums in general. And I found there's a significant problem of access, about access to high culture. I'm sorry to use that word, high culture, but unfortunately, there is a high cultural definition. And so we started working as a 20% project, as a hobby project, to try and get museums to convince them to put their artworks online and not be afraid of what happens with the physical attendance, because we felt confident that once you see something you like online, and if you know that you can actually see the real thing, you will. Because that's, to be honest, what happened with me. So we started that project, it went well, and essentially, we started doing work with around 1,500 museums. So we set up a foundation within Google. So we're a separate non-profit foundation, a small group of engineers, and we work with archives, museums, etc. So what happened is we started getting a lot of data. I'm coming to the ML part, so bear with me. We started getting a lot of data, and we ended up with the largest collection of artworks online in ultra-high resolution. And it was made available to everyone for free. It's all on the platform. It's all great. But we started experimenting with the data. We started figuring out what can we do when we apply ML or other techniques to see what insights we can get from that data. So that was the idea on how we went into the ML phase. And now I'm going to welcome on stage a very close friend of mine, and not a Google person, so you can be more gentle to him if you want. I know what some of you, have that maybe think about, where I am. So I just wanted to make sure that I have an artist with me. He is the true artist. He's the artist in residence at the Cultural Institute. He's also the head of, he's a professor actually. He doesn't look like one, but he is. He's a professor of interactive design at École University in Switzerland, who we've been working with very closely. So he's going to help me show a few things. But before we get into it, we're going to switch, I think, to Cyril's machine. Okay, great. So anyways, remember all that stuff I was telling you about 1,500 museums, blah, blah, blah? Well, that's all accessible here. Every day, in fact, yesterday we just launched the Mayan collection at the British Museum. Maybe some of you read about that. So we work with Guggenheim, Bilbao. And the reason why, by the way, I'm in this let's say, fashion environment is because a year or two ago, a colleague of mine who's in the audience, Kate, convinced us that if you think art was exclusive, you need to try and see what fashion is, and you need to try and bring fashion to the masses. And she really convinced me to work with around 183 fashion archives and museums to bring their collections online, which we did this year, and that's how we got in touch with Imran, and that's the story. So moving on from this, I have to show you one quick thing. There's a lot of content here, a lot of stories, etc., all owned by the museums, by the way. Let's just tell you what started things off from technology and culture, because I'm going to keep coming back to this thing that technology and culture can help each other. And one of the things we did in 2011 was find a way to do high-resolution scanning of artworks. So let's pick one of my favorites, which actually I saw it in a digital version, and then I have been to see it in real time 11 times. So let's search for The Birth of Venus at the Uffizi. So that's The Birth of Venus, and we have the entire Uffizi collection. You can enjoy it. But we started doing these and you can read about the story from the curator, et cetera, et cetera. But you can also very quickly start navigating through this artwork to really understand stories about it at ultra high-def resolution without anything at all, just on your phone or whatever. So you can really get to brushstroke level details. So Cyril's going to do that practically instantaneously, and there you can see this. So this is available for like 7 million artworks over here, so you can enjoy those. And if you zoom out a little bit, you can start seeing details that you could not probably see before, like, for example, this breadth. And obviously, zooming and all is fun, but after you zoom 10 times, you actually want to learn more. And that's the idea, right? Zoom is just a way to hook you in to something deeper. And I learned that the reason you have this effect is because it was one of the first paintings to use egg yolk in the production process by Botticelli. So anyways, moving on. What we did then is, we said, okay, we have all these amazing artworks, ultra high resolution. What do we do if we let a computer, using machine learning, using something called Deep Dream? I'm not going to explain to you what Deep Dream is. It's a bit technical, so I'm going to skip that part. What if you gave the computer its own journey through all these high-resolution artworks? How would the computer navigate it? So it's essentially training the computer or the algorithm to take its own journey, to make its own selections, to just create its own hypnotic kind of experience of these artworks. So we're going to play this video. We have never shown this before publicly. We're going to play this video that shows you how the machine is navigating through this collection without any human supervision. So whatever you see is being chosen by the intelligence. So we can play the video. So it starts with an artwork. There's no music, so I'm going to have to speak, unfortunately. So we keep going in, and the machine then starts saying, OK, I'm going to move from there, and I'm going to try and come into maybe a scene from a Renoir painting because of visual similarity. Now, where do I go? Now, I mean, as a human, I might go to more Renoir. I don't know what he's going to do. So let's see. And it's taking its own journey into another artwork. And I don't actually know which one that is, by the way. But see, you all are experts in the world of art. And then where are we going to go? You may start seeing a pattern here. Color similarities, object similarities. That's a better way to understand machine learning because it's the practical ideas rather than the theory that you can actually see. And here we are. And I think it's going to now take you into actually, where do we go from this one? I think we go into a nice, beautiful field, just not as cold as outside. So this goes on for hours and hours and hours. And Imran has told me I don't have that much time. So let's move on. So I want to take you through this journey, get an experience. Now, what we're going to show you, we have actually not done before or shown before. And I'm going to get Imran actually up on stage so that he can tell you a little bit also how this came about. But in essence, this is not a data set we're used to playing with. But you know, when Imran wants something, as most of you may know, he gets it. So he convinced us that he has to have this. So.
That's not quite how it works.
Oh, trust me, it's true.
Oh, goodness. So no, I mean, Amit, thank you, first of all, for taking us through that amazing visual journey. But earlier this year, I spent some time at the Google Arts and Culture Lab, where Amit is based, and brainstorming with Cyril and Laurent. I mean, everyone was on different screens. It was a very Google Hangout moment. And we were trying to figure out, like, if this artificial intelligence is, you know, becoming such a prevalent part of the way everything is happening in the world and solving problems for us, like, what problem could it solve for the fashion industry, you know? And they, you know, the Google people came with some ideas, and I was like, oh, I'm not so sure about that.
Our ideas were better.
Yeah. But we had this, like, data set of images, right? Let's call it Fashion Week, right? And ever since when Tim joined us a few years ago, BOF didn't cover Fashion Week before that, but ever since Tim joined, we started gathering all of these images. And as we started building this image database, we started adding, you know, it started with London, New York, Milan, and Paris, and then, you know, we got calls from Sao Paulo and from Tokyo and from, you know, Korea, and eventually BOF Fashion Week represented, you know, 20 or 30 cities around the world, all sorts of shows. But how do you try to make sense of that? You know, every season in the fashion magazines, you see those collection stories, and they say, you know, it's military, and then it's this color, and then it's that color. But I was wondering, and I asked the Google team, I said, well, what could artificial intelligence tell us about Fashion Week through color? So let's have a look.
Yes, and just to be clear, his idea was better because he had better data. And whoever has better data wins, right? So I just wanted to ensure that you don't think that our idea was better than his. So before we get started, he gave us 70,000, I think, high-resolution images of the last 4 years of fashion shows for a large number of designers, most of whom I did not know about until I started playing with this data set. And this data set, we said, okay, what do we do with this data set? First, to try and organize it, because I cannot show it to you if it's not organized. So Cyril is going to start, and remember, this is an experiment, so low expectations, okay? So this is a map. Forget the models on the catwalk for a second, because we had to unfortunately extract them out of the equation for 1 minute, and just look at the color patterns that were emerging. So this is a kind of a visual map of the color patterns, and Cyril is going to slowly start zooming in. So you start seeing clusters, right? If you've noticed, there's clusters of red, blue, gray. You know, I always thought that you wouldn't see so many different variations, but there are. And all these are, by the way, each one of these squares actually means something. We're going to show you what it means. But right now, it's essentially an artwork in its own right. It's a nice, beautiful, minimalist square. And if you want to, let's say, Cyril has selected that square. And if you want to see what that square results to, here is the art. Here's not the artwork, sorry. The actual runway shot. And so you can navigate through these clusters to look at different designers by color for 4 years of data. We did this in a couple of weeks. So imagine what you could do with 7 million, 10 million data sets very, very quickly. So you can very quickly start seeing the different shows. But then I think it gets even more interesting when you perhaps search for a particular designer. So let's open up the search option and start with, I think, my favorite maybe, yeah? Well, it's my favorite because I thought it was all going to be black and white, and apparently it turns out it's not. It surprised me. That's why it's my favorite. Not because I buy Issey Miyake. I may. All right. So this is 8 different shows of Issey Miyake organized by color palette. So this is a palette. Okay, so if any of you is a graphic designer or something, you'll understand this is just now extracting color palettes. So to do that, you have to teach the machine how to identify which colors to take. Because if we take, for example, the background color, we might end up with a very similar color palette for everything. So this is where the intelligence comes in. I keep going back to help you relate why this is helpful from a machine standpoint, and why is it difficult, I mean. So you can navigate it, you can understand it, and if we switch the color palette, you see exactly what it relates to. So you can do that for, and here's the color. You know, I didn't think Issey Miyake was big into color, but I love it. You know, it's phenomenal. And I mean, I'm sorry, I know you all are looking like, who's this guy? But, you have to understand, I'm not from your world. So it's a lot of fun for me. All right? So, you know, so it keeps going on. You do this for as many designers. But let's do it for another designer. I think, let's call it Cyril's favorite designer. Let's do, not designer, design house, Chanel. And let's choose, I guess, what do we want, Cyril? So now we've established the color palette pattern for all the different shows for Chanel. So if you're a fashion editor who very quickly wants to look at color palettes, you can imagine what this could mean. Or if you're a student, you can imagine how this can be helpful. Many, many reasons. But what I find really exciting, because I'm obsessed with because of the We Wear Culture project that we did around fashion, I got obsessed with materials. I really never paid much attention to materials before, but I got obsessed with lace, with embroidery. And so what we try to get the machine to figure out, Cyril, before you do it, what we try to get the machine to figure out is, can you extract materials from these without any, by the way, none of this is human intervention. You have to understand that. So it's already quite, you know, it's like teaching a baby to take more and more steps. And so if we activate labels very quickly, you can now start sorting based on different types of materials, styles, whatever the algorithm is being trained on. So as the algorithm evolves, as it gets trained to identify these, it's not a perfect science. It's not perfect. Remember that. It's an experiment. But you can start looking at different things. So for example, if you want to look at lace, I don't know, Cyril, if you have lace somewhere. Lace is my new favorite thing. It was on top. It was on top, Cyril. I think I saw it. There it is. OK, so if you want to see in this show specifically which object refers to lace, in less than a second, you get it. And obviously, the idea is then you could do it throughout the collection. We didn't have time to do that. But for example, you could just type in lace and see every single model that's wearing an outfit that has lace. And then you can start deciding if you want to buy it or not, or maybe not. So essentially, I think, Cyril, that's pretty much our experiment. I hope you enjoyed it. One view I'll leave you with. Thank you. It's this man and this man. And one view I'll leave you with, because after we looked at all this data, just so you know, we were like, this is all great, but what if you want to just try and create a cool game visualization? So we launched something called 3D View. This is really for us. And this is a way to navigate it as if we were playing like a really interesting game. And you can choose different things. You can go into them. And this is a talk by itself for another 15 minutes. So thank you so much for having us. Thank you, Imran and team. And thank you, Cyril.
That was
I hope you enjoyed
amazing.
it.
Take them out. Cyril, thank you.